Wednesday. You have an exam due. Let's go ahead and turn that in.
So, it's got a little bit of scrap paper on it, the corresponding questions at the top.
That's why I made a write your name on those in case it gets separated.
All right. Okay.
I'll just write my name in the gold.
Ink is on off a little bit.
What do you think? Easy? Easiest exam of the semester.
Oh, that's.
I'm kidding. It's the hardest exam probably.
Oh, good, okay.
Techniques is the hardest. Techniques is the hardest thing we do all semester.
Oh, good.
Because now we can just use the CIS to evaluate integrals for us.
Yeah.
Except on the final, where
Yeah.
I'm actually going to test you again on if you can take an integral. We move on to applications of the integral. Starting with a bit of review, possibly from Cap 1. Let's say there's some function f of x. Let's call that b. Right? You're asked to find that area. What is it?
Would it be the integral of f of x from a to b?
That's your area.
All right.
I'm just getting two different colors. Let's say there is a new function g of x. What is the area in blue?
I believe it would be. I think it would be f. It's a composite function, I think. Just trying to think which one.
Just the integral of g of x,
Yeah.
a to b.
That's just the area under g of x, right?
Yeah. Oh, yeah, because we're still using the same ones. Okay.
want that area, the green area, which is between F and G.
Oh, so you just find the area of f of x and then minus the area of g of x.
Right?
Yeah.
Because isn't the green all of the yellow area?
Yeah.
And then take away that blue area? Notice in this case, of course, f is larger than g over that interval, right? So larger function minus smaller function, larger area minus smaller area. Should never get a negative area. If you do, you did something wrong. Either you flipped the order or you did calculus wrong. And fortunately, you're probably not going to know which one it is. Integration is what we call linear. Right? It's a linear operator. So it satisfies the linearity properties. So you can write that as a single integral. Integral from a to b of f of x minus g of x dx. Again, larger function minus smaller function on the interval. That's all area between two curves is. One of the easiest derivations. Sadly, the rest of the derivations we do in this unit are not so simple. We have to go back to the definition of the integral with Riemann sums and the limit.
So are those the same thing? Those two that you wrote in white?
Yes.
Okay.
Like, because technically what we're doing is, right, this is the larger area. That's the yellow. This is the smaller area, that's the blue. But you can write it as a single integral because it's linear.
Oh, because, yeah, between the plus and the minus, it's almost like you're doing it,
Yeah, it's plus negative 1 times. So I can use the linearity properties to write that as a single integral.
okay.
So we will be using Mathematica tonight just to kind of get an idea of what the areas look like. So first we're asked to plot the region between the curves of sine of x and cosine of x from 0 to pi over 4 and then find its area. So here's what I'm going to do. I'm going to call this plot 1. We're going to start by just plotting the two curves. All right, so I have two curves, so I need them in braces. Sine x, cosine x. Need a domain. For now, let's just start minus 2 pi to 2 pi. Yeah, but I'm gonna start with a broader picture.
Okay.
I want both graphs to be black. And plot labels. As expressions. This will actually then label each curve, so we know which one is which. Oh, duh. Forgot to put X here. So there we go. Here's one of the disadvantages of the online version. I can't edit that. On the desktop version, I can. I can actually move the labels around. I can actually also edit the graph with text and anything else I want. Can't do that on the cloud version. So we'll make do. Area we're looking for. Is this region in here, right? Sine and cosine are equal at pi over 4. So I know that that is pi over 4. So it's just that area there I'm looking at. So there are two ways we can go about this. We can now just shrink our domain down just to have that area. So what I'll do is I'll just copy and paste. Right, so this is the area. I can make it a little more obvious. This is what I'm now gonna call this area. I'm gonna fill it. Filling. There are several ways to fill it. The one I'm going to use is between graphs. That says between plot 1 and plot 2. Right, so plot 1, sine of x, plot 2, cosine of x. I think I could also flip it and go 2 to 1. Doesn't matter. Now we need a style. So it has several basic colors built in already. right? Black, blue, if I can spell, gray, yellow, green, pink is in there. Although it's not really pink. But you can use any color you want if you know it's RGB code. Normally I have fun and I just let it randomly choose. But let's actually look one up. I stopped using this because they've stopped updating it. Ah, perfect! Coffee. No! Disappeared. Coffee. Classic coffee. Turkish coffee, black coffee, rich coffee. Oh dear, so many. Let's go with classic. Why not? All right, so there is my RGB code for the color I'm going to use. Oops. I'll just go ahead and copy paste. Now, with Mathematica, they want it as decimals. So each entry should be a value between 0 and 1. So how do I adjust this? Well, if you're familiar with the RGB coloring schema, it goes between 0 and 256. So I'm going to divide each term by 256. That'll get me my color. Close that out. Right, because now it's obvious. It's this region I'm looking at, not this region down here, or possibly a region up here. Another thing I can do, I don't know how it's going to work with those. Let's find out. Is I have those two already stored. Now I can just show them together on the same axis. So the first one is like your default one. Everything else you list after that is going to be shown on that axis. So I want to show plot area on plot 1. So I do plot 1 first and then area. And that's what I thought. It's going to show that label twice, so I would just come up here and I'd delete the plot labels so that these disappear, and I would just show it without that. Right, so either way, this now shows the area that we're trying to find. So you can do a lot of cool things with Mathematica. First, we want the integral setup. It's going to be an integral. What's the lower limit? What's the upper limit?
4.
So we integrate from 0 to pi over 4. Larger function minus smaller function. What is our larger function? cosine. Minus. There's the setup. Read the question carefully. Some questions may only ask you to set up the integral. If that's the case, that's where you would stop.
By larger, it means like the one that is above?
The values are larger, yes. I don't want to say above because if we integrate with respect to the y-axis, you know, when we go above, below, but it's the ones whose function has larger values over that interval. In the case of the x, yeah, you look above. What is the antiderivative of cosine? What is the antiderivative of sine?
Negative cosine.
Sine of pi over 4 is what?
Square root of 2 over 2.
What is sine of 0?
Negative 0.
Alright, so I don't need to write that, it'll just be minus 0. Now, plus, what is cosine of pi over 4?
The same.
Minus, what is cosine of 0?
1.
Minus 1. So how I do fundamental theorem calculus, I actually just go term by term. So I evaluate cosine pi over 4 to 0, 0 to pi over 4 first, or sine pi, 0 to pi over 4 first, then I do the cosine. Whereas typically you're taught to evaluate the whole thing at pi over 4 and then subtract the evaluated at 1. But because, again, the integral itself is linear, I can write this as two separate integrals, and then it would be evaluate this 0 to pi over 4, then that 0 to pi over 4, so that's how I do it. What does that simplify to?
Is that just simplified to root 2 over 2? Maybe negative root 2? So I think if you add them, wouldn't it kind of be like 2 root 2 over 2, but then minus 1?
Square root of 2 minus 1.
Root 2 minus 1. These two added together would be root 2. And then minus 1. You can't do anything with that.
Oh, yeah, okay.
There's your area. Remember, unless you're specified otherwise, you leave your answers in exact form. I do not want the decimal approximation to that, unless I ask for it. Be advised, my math is the same way. If you put in the decimal form and didn't ask for it, it may mark it wrong. Well, that was easy. Nothing like the integrals you had to do on the exam. So I want to plot the region between these two curves and then find its area. Notice how this time they didn't give an interval. All right, let's start with plotting it. And now when I rerun this, it will overwrite the previous plot one. So again, we have two curves, 6x minus x squared, and then x squared minus 2x. Start with a domain. You can't do that. Mathematics doesn't, you can't ever plot infinitely long intervals. Because it would literally take an infinite amount of time to do it.
Should we just like pick some numbers?
Yeah. What's the standard viewing window? Minus 10 to 10?
Yeah.
Start with that. Let's see what that gives us. Oof. That's not really bloody helpful. It automatically chooses a domain for the y-axis. But we can also set it to whatever we want. Huh? Right, range. Why is it coming up red? Uh-oh. They changed something on me. Oh, never mind. Plot range is what I want. Okay. So plot range, and then I can set that to whatever I want. So again, standard viewing window, minus 10 to 10. Much better. All right, so what is the area we're looking at? Well, it's the region between the two curves, right? So it'd be in here, right? So for the most part, it's going to be the same.
How will we determine which of those is bigger? They're both of the same degree.
6x minus x squared.
That'd be the larger function for the interval.
Okay.
When we shrink it down, it'll become more obvious.
Okay.
Right, but you just look at, okay, this is our region. What's your top function? What's your larger function? Because we're doing x.
Oh,
Right, larger means above
so
in terms of the x. So it's this one here, which is that 6x minus x squared.
okay.
It's obviously not going to go minus 10 to 10 on x, right? What is it going to be?
0 to 4 to 5.
We want to be more precise than that. How'd you get 0 to 4?
I just kind of eyeballed it. Looks like the point that it ends looks like it's before the 5.
What do you mean where it ends?
Well, the area that we're looking at, if you draw like an x-axis, the point where
What is the term for that? What's the mathematical term for that? It's where they intersect.
Yes.
We're looking for points of intersection. How do you find points of intersection? Yeah, set them equal to each other and solve. Now remember, double equals.
And this is the actual equation, the original equation we're saying equal to.
We're setting the two curves equal to each other.
Right, not the integrals.
And solve for x. And again, I like it in table form, so. Yes, 0 and 4. You don't want to just eyeball it from the graph. Because it may not be exactly 4. In which case you're not going to get the exact area. I'm going to get rid of the plot range for this one, I think. Because it should, because I'm now restricting the domain, it should just give me a nice picture. Again, I want to go between curves. That looks like a cool color. There's our region. Right now you can clearly see from here, right? Larger, 6x minus x squared. Smaller, x squared minus 2x. If you didn't have the plot, how would you determine the larger function?
Some values from the region.
Just pick a random value in your interval, plug it into both ones, whichever one's larger is your larger function. Because remember, we already found where they intersect. So between those intersections, one is always going to constantly be larger. Everywhere in that interval.
So in that case, you would find the intersection first.
Yes. Because you want to find your interval first.
Right.
And then determine which one's larger.
Okay.
Right? Because again, the only way for it to switch from being larger to smaller is it has to cross through that function to dip below it. So it's never going to do that between your points of intersection. Much like when you study Calc 1, increasing, decreasing, right? You just pick the test value in your interval to determine is the derivative positive or negative. The reason you do that is because the only way for it to be different is to actually go through 0. But your test interval is set up where it equals 0, right? The critical points.
Yeah.
Excellent. We have everything we need. So set up the integral first.
6x minus x squared. And then, probably gonna put that in parentheses. And then minus x squared minus 2x. That's also in parentheses.
Do not forget your parentheses. And now let's simplify that. 6x minus negative 2x. Negative x squared minus x squared. Can factor out the constant that's common too. There's our integral. Now evaluate it. What is that antiderivative?
Should be negative 2/3 x cubed plus 8x. Well, I'm sorry, I didn't do that with factoring out the 2. But.
So you said what?
So I had, I guess if you factor out the 2, it would be negative 1/3 x cubed plus 4x. I believe.
I agree. Minus a third x cubed.
2x squared.
2x squared. And power rule on x squared over 2, right?
Yeah. Oh.
So it'd be 4x squared over 2.
Okay.
Just 2x squared.
Yeah.
X squared is 16 times 2. 32. When it's 0, that's just 0, so we don't need to worry about it. Minus 4 cubed is what? 64 over 3. And again, when it's 0, it's just 0. So 2 times 96 minus 64. 32. Sixty-four thirds. All right, so that area is 64 thirds square units. And whatever the units happen to be. Assuming I did the mental math right. Which I did. Perfect. Plot the region between y squared equals 4x and y equals 2x minus 4. We also want to find the area of that region. I'm going to now call it plot. Okay. So the plot command can only be used to plot curves of the form y equals f of x.
So probably that y squared is going to have to be the radical for x.
One of our curves is not of the form y equals f of x. And no, you can't just use radical x, radical 4x. That'll only give you half of it. So there are two ways to do it. In this case, it is simple enough to solve for y. You get two functions. Not every curve is going to be that nice, where you can actually explicitly solve for y. So to plot implicitly defined curves, we use the contour plot command. Thank you for that. Right, so again, I have to use a double equals. Y squared equals 4x, that was the first curve. Y equals 2x minus 4 is the second curve. So with contour plot, we need two domains. One for each of the variables. X and Y in this case. Again, standard viewing window is minus 10 to 10, so that's one to use. And technically, that is all you need. But here's what it gives you. Which is ugly. I'm going to adjust that. First thing I want to adjust is the color, because the default colors in Mathematica are hideous. I want my curves to be the standard, so contour style black. I don't like it being in a box. All right, that's not typically when you plot something, you don't have it in a box. So I'm going to turn the frame off. But I don't have axes. So I'm going to turn axes on. That should be good. Perfect. That now gets it looking like what we're used to. What is our region? Well, it's this bit here, right? Unfortunately, Actually, I shouldn't say that because Mathematica did update and they may have changed it. Yep, nope, okay, good, they haven't. Unfortunately, the filling option cannot be used with contour plot. So if I want to shade the region, I'm going to have to use plot. Oh, I forgot to label those. Is it plot labels still? No. Oh, crap. I can't do plot labels either. I forgot. Plot labels is not a thing in contour plot. Yeah, contour plot definitely has its drawbacks. Thankfully, I can tell which one is which. I'm going to have to use the regular plot command in order to shade it. Thankfully, this is a nice one that we can do. We have 3 curves to consider. This upper curve, this lower curve, and then the line. The 2 curves you get from y squared equals 4x. Negative 2 root x and 2 root x. Which of those 2 gives you the lower curve?
Why do we break them down into 2 groups if it's the same function?
Because y squared equals 4x is not a function. Vertical line test. Fails. So yeah, I agree it's a single curve, but it's not a single function. And the reason you get 2, what's the square root of x squared?
Or x and negative x.
Which is said how?
Plus and minus.
Absolute value of x. So square root of y squared is the absolute value of y. So you get absolute value of y equals 2 root x. Which means y is either positive root x or, I'm sorry, positive 2 root x or negative 2 root x. That's why you need 2 of them. Which of those 2 is the lower curve?
I would think negative.
This one down here?
Yeah.
Yes. So which of the 2 is that? The negative one, right?
Yeah.
So negative 2 root x is the lower curve. Positive 2 root x is the upper curve. So that's how you can plot a sideways parabola if you can only do plots in the form y equals f of x. And then we have the line. We need a region. We need an interval for the region. Well, we're obviously going to be solving. Two ways to go about this. Right, look at the plot, you can say, okay, we're gonna have an intersection there, lower curve, lower part of the parabola with the line, so you can just set those two equal to each other, solve for x. That'll give you that point of intersection. Then you also have this one up here. Right, that'd be the upper part of the parabola, intersected with the line, solve that. That'll be your 2 points of intersection. Or y squared is 4x. Oh, actually, it's gonna. Yeah, no, so I can do it this way. Y is also 2x minus 4, so take 2x minus 4 and plug it in here. 2x minus 4 quantity squared is equal to 4x off for x. Because remember, if you're finding the point of intersection, it's where they're equal. Which means these two y's have to be identical. One of them says y is 2x minus 4, so just square it. That gives you what y squared should be. I think that's the route I'm going to take. You get 1 and 4. Here I want to use one of the standards. If we use what we've been using before, that's what we get. That's no good. So what if we do 2 to 3? That's no good either. And I forgot to do this. Plot style. Get that in there. That's no good either. That's not what we're looking for. Could try to just do 1 to 3. No, that's not it either. Oh dear. Notice we don't even have the right origin. Notice where it intersected, where it put the origin. Put it at 1, 0. So I'm almost gonna have to fix that now, which is perfect. Set you at 0, 0. Now run it. All right. So as you can see, something is terribly wrong here. Yes, our point of intersections are 1 and 4, but is that our interval for the region? No. It's what? So that would be 1 to 3. I actually don't need the axes origins in there anymore. We did 1 to 2. We get that. And then 2 to 3. We get that, which none of them is what we're looking for. This is because we actually have 2 regions. At 1, right? So if you go 0 to 1, what is your upper function? Right, so if I do, so instead if I do this, let's get rid of the filling for now. Maybe look at it here.
Isn't there so far only really one function? Technically?
Do it this way to make it easier to see. So from 0 to 1, what is your larger function?
0 to 1 would be 2 radical x.
What is your lower function?
The 2x minus 4, or the negative 2 radical x.
Negative 2 radical x. Now go 1 to 4. What's your larger function? What's your smaller function?
2x minus 4.
You have 2 separate regions. One region goes 0 to 1, the second region goes 1 to 4. Get rid of the expressions. So from 0 to 1, it was, you said 2 root x to negative 2 root x, right?
Right.
Which is plots 1 and 2 here. So the filling will go 1 to 2. This blue. For now. Notice I'm using colon equals here so it doesn't spit out 2 plots. I'm going to keep it right now the same. Oops. I said copy. The only thing that I'm going to change, there's two things I'm going to change. The interval goes now 1 to 4. And we said it was now 2 root x to the line. 2 to 3. So that's the second thing I'm going to change. Now, what happened? What happened? Oh, you know what? I think I want to do this. Yeah, there we go. There's how we shaded our region. If we go dx, you have 2 regions you have to find the area of. I'm going to change that to light blue. Oh dear. Wow, that didn't really work the way I was hoping. So let me do this. Red and pink. That's better. And you can see that's not really pink. They call that pink. That's not pink. But you have those 2 regions now that you have to find the area of. So our area would be the area of region 1 plus the area of region 2, right? Sum of the 2 areas. What is the first area?
-2 root x to 2 root x. No, wait. You're looking for an equation.
Limits first, limits of integration.
Yeah. So -2 root x is it's not
0 to 1. What's the larger function?
2 root x.
What's the smaller function?
-2 root x.
Now, second area.
1 to 4.
Larger function.
2 root x.
Smaller function.
2x minus 4.
Now we have to solve both of those integrals. Well, this is just going to be 4 root x, right? That's nice. Plus, now here we can factor out a 2, be left with root x minus x plus 2. Antiderivative of root x.
X to the power of 3 over 2 divided by 3 over 2.
And what is 1 divided by 3 over 2?
1 times 5.
3 over 2 is 1.5, which 1 over 3 over 2.
2/3.
2/3. That goes from 0 to 1. Oh, that's beautiful. That's going to be nice. Plus 2. Oh, look, we have root x again. Don't reinvent the wheel. Antiderivative of x. And then antiderivative of 2. That goes from 1 to 4. That's not as nice. At 1, x to the 3/2 is 1. At 0, it's 0. This is just 2/3 times 4, so that first one is just 8/3. Plus 2 times. What is 4 to the 3/2?
Is it 8?
It's 8
Yeah.
times 2/3. And then go minus when it's 1, which is easy. Minus 4 squared over 2. Minus negative, so at 1, a half. 2 times 4 minus 2 times 1. Eight thirds plus that was nice. Minus 8 plus 8, that's 0. That's 14 thirds. Minus 2, 14 minus 6, 8. 8 thirds. 8 thirds plus a half. What, 16 plus 3, 19 sixths? 19 times 2?
38.
What's 8 times 2? 16. 16 and 38, 54?
Yeah, 54.
54 divided by 6?
9. Yeah.
Area is 9. Oh my. What if I told you there's an easier way?
Nice.
So instead of doing it with respect to x, do it with respect to y. Now you only have one region. Bounds for y. So the lower bound for y is going to be this point of intersection, right? Well, we said x was 1 there, right? So if x is 1, what is y?
That's the 2x.
Negative 2, right?
Yeah.
The upper limit for y would be this point of intersection here, right? We said x is 4 there.
Yeah.
So it'd be 8 minus 4. Except now, instead of going up, down, right to left. Larger function is the line, right?
Yeah, 2x minus 4.
But that's y equals 2x minus 4.
Oh, you
We now want x equals a function of y.
So we gotta solve for x.
Yeah, it's not hard to do though.
Right.
Y plus 4 over 2.
Yep.
Which would be
Y plus a half.
y over 4 plus a half. No, I'm sorry. It's plus 4. So it'll be plus 2. Right? Y over 4 plus 2. Minus your smaller function is now that parabola, which was what? Y squared equals 4x. So what's x? Now we just have a single integral.
I think that'd just be 1 half, right? You're pointing at -2 there.
What is the antiderivative of y over 4? I'm starting to get a headache. Antiderivative y over 4.
1/8 of y squared.
Y squared over 8
Yeah.
of 2. Well, that's easy. Plus 2y. What about y squared over 4? Y cubed over 12. Evaluated. Negative 2 to 4. 4 squared. 16 over 8 is 2. Minus. Negative 2 squared is 4. Over 8's a half. Plus 2 times 4 is 8. Minus 2 times negative 2. Positive 4. Minus 4 cubed, 64. 64 over 12.
16 over 3.
That sounds right. Minus negative 2 cubed is negative 8. That's going to wind up being plus 8 over 12. 2/3. Ten, 14. That's negative 14 thirds. Negative 14 thirds minus 1 half. Negative 28, no, negative 32, I should say 32. 32 plus 3, 35, so minus 35/6.
Would it be negative 31 over 6? Negative 14 thirds minus a half, minus 3/6.
I did 16, yes. 14, yeah. 28. 28 plus 3, 31.
Yeah.
31/6. 14 times 6.
84.
84. 84 minus 31. Oh dear. What did I do wrong? This is what I did wrong. It should be minus. Minus minus is plus, and then negative 2 cubed is negative. So that should be minus 2/3. So that should be 18 over 3. 18 times 2, 36. 36 plus 3, 39. And then 39 over 6 is 13 over 2. 28 minus 13.
15. Over 2.
Which is not right. I'm doing mental math wrong. Eight minus negative 4. 4 cubed is 64. 12. It should be 16 over 3. Right, and then minus. Is 10, 10, that's 14. This one, let's bring calculator. Not. That's right. Where's my mental math getting wrong? Y squared over 8 plus 2y minus y cubed over 12. I know that's what it should be. Wait a minute. Found my mistake. Mm-hmm. Should be y over 2, not y over 4. That's your fault. You told me y over 4, and I went with it.
Oh, wow.
It's actually not too difficult to fix. Y over 2, which makes this y squared over 4. Or squared 16, 16 over 4 is 4. And then minus 1. Let's try that again. 3, 7, 15. Minus 18 over 3. 15 times 3 is 45. 45 minus 18. 27 divided by 3.
That's a good answer.
9. Set it up right, that's easier. Watching you. So this problem, 2 purposes for it. The first one was to show you have to be careful because you may wind up having multiple regions that you have to set up. The other purpose is to show you that it might be easier to go with respect to y instead. Right? And vice versa. This problem's cool. I like this problem. Right, so we're going to plot the curve y squared equals x squared minus x to the 4th, and then we're going to find the area enclosed by the curve. Enclosed by, well, that's new. Contour plot y squared equals x squared minus x to the 4th. Start with the standard viewing window. Obviously, that viewing window is too large. So adjust it. And this is where you can kind of see from here. I'm going to go just a little bit further out than what the actual plot is. Right, if you look, it's actually -1 to 1, right? I'll just go a little bit further out. Oh, wait, oops. Oops. I did Y. I want to do both. That symbol should look familiar. Yeah, it looks like the infinity symbol. I honestly cannot tell you why it's cutting that portion out. I don't know why it's doing that, because when I did it on the desktop version, oh, actually it did cut something out in the desktop version. It cut the lower part out. I don't know why. It shouldn't. This symbol actually has a mathematical name. Can I pronounce it? That's the question. Yeah, I'll just add it in here. Why not? It's called a lemniscate. We'll be revisiting that terminology towards the end of the semester when we look at geometry with a plane. It's a lot of cool curves. So we want the area enclosed. So now you see why we say enclosed. So we want all of this area. Well, what you should notice, this region, aren't they identical? They're identical. So pick one, this one. Double it. That'd be the total area. Oh, but wait a minute. This region and this region, aren't they identical? Ah. So if we find, say, this area and double it, that gives us this entire area. So all we have to do is find the area of this part up here and quadruple it, and that's our total area. Well, that means integrating with respect to x is fairly easy. Right, because we only have one region now. Versus we normally would have to do two regions. Now it's one. And we can actually now cut that in half, which makes it even easier. So, lower limit for x. Upper limit. 1. It's 1. Lower curve is the x-axis, right?
Yeah.
So actually what we're doing is we're just finding area under a curve. All we need is y equals f of x.
Yeah.
But y squared was what? X squared minus x to the fourth, right?
Yeah.
We want the positive curve, because it's the one that's above the x-axis. Isn't that just the square root of x to the fourth x squared minus x to the fourth?
Yeah.
There's your area setup. How are we going to do that integral?
Is that on the table?
No.
Okay. So like, it's an identity or something.
I'll give you a hint. It's a Calc 1 integral. All the problems we did were Calc 1 tonight. You could just plug it into a cast, but that's no fun. Did you factor an x squared out from what's under the radical?
Yeah.
Square root of x squared is absolute value of x, but we're on the interval 0 to 1. Isn't x always positive there?
Yeah.
So it's f just positive x. Isn't that a u sub? Let u be 1 minus x squared.
Yeah.
Du is negative 2x.
Should that be x squared right there, or not x, or it should be?
No, it should be x. Because remember, I'm factoring x squared out from the radical, from under the radical.
But it's a radical.
Square root of x squared, because I'm on 0, 1,
Yeah.
is just positive x.
Okay.
If I was negative 1 to 0, it'd be negative x.
Okay.
Poor pencil, what does that ever do to you? I'm sick of this shit. So I need a negative 1/2. Right, because it's negative 2x dx. I need a negative 2 here. So minus a half. Then it's just u to the 1/2. 2/3 u to 3/2 from 0 to 1. At 1. This whole thing's 0, isn't it?
Yeah.
So minus, at 0 we get 1 to the 3/2, which is
1.
So I actually got to multiply the whole thing by 4. I was only quarter of our area. So I really should be doing this.
If it's multiplied by a negative number. Oh, that's also a negative. I didn't see that. Okay.
Negative.
Okay.
Yeah, it would have been bad if this wasn't negative in here.
Yeah.
Then I would have gone, oh, I did something wrong.
Yeah.
Thankfully, it was negative. So negative, negative, positive. 4/3 is that total area. Use symmetry to your advantage. Yes, 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 I know battery's running low. Poor baby. Toughen up. Questions on area between curves. I say toughen up. No, it better not die on me. If it does, I'm going to be very sad. There's my mouse. So the next set of assignments in my math have now opened up. They will be due March 13th. You can work on assignment 8 at this point. Your first mathematics assignment is also now up. What's this? Nobody's turned it in yet? So disappointed. All right, so just giving you a brief review of the numerical techniques. Error function. 2 over root pi times the integral from 0 to x of e to the minus x squared dx. That should probably be t squared dt, but it doesn't matter. Groups of no more than 3. I think there's 8. So it's going to wind up being 2 groups of 3 and 1 group of 2, or if you want to just do 4 groups of 2, whatever, don't care. However you divvy it up, it's fine, but no more than 3. If you want to, you can also just work on your own. I don't recommend it, but you can. You're going to use Mathematica to evaluate each of those 3 values, erf of 1, erf of pi, and erf of phi, the golden ratio, accurate to 9 decimal places using each of the 5 numerical approximations: right, left, midpoint, trapezoid, and Simpsons. That's why I don't recommend you try and do it on your own, because that would be 15 you have to do total by yourself. You will submit just 1 copy per group. I want the entire Mathematica code, input and output printout. Right, so like we were doing in class that day, the input's the actual code, you hit Shift Enter, that's your output. You do that for each of the problems. Mark, which one is which using the parentheses star, parentheses asterisk. I showed you as a comment to signify what you're doing. That will all be due at the end of the month, February 28th. Yes, you have 1 week. February 28th. Hard copy turned in. Again, if you want to upload the electronic copy as well to be safe, go ahead. Problem with that is if you're using the Wolfram Cloud, that means you're going to have to download it. You're going to have to download the file. You should be able to print it as a PDF if you want to upload it. I would recommend you do that. Print a PDF and then upload it that way. Make sure that every group member's name is on the assignment. Right, every group member is going to get the same score, so I need every name. If you have any questions, don't hesitate to reach out to me. Today is Wednesday, right? Have a great weekend. Have fun with the Mathematica project. I'll see you Monday.